Hi everyone, it's time to do section 6.8. Today we're going to learn how to add and subtract rational functions. We're also going to start off with a little bit of review, so let's jump right in. All right, so the first thing we're going to do is find all the asymptotes and intercepts for this beautiful rational function. Whenever you have to find all of this stuff, sometimes it's helpful to go ahead and just factor everything first. So I'm going to go ahead and factor the top. I know I'm going to have a 2x and an x. I'm going to put 1 and 6 because I know that 12 and 1 is going to somehow make 11. I want plus 12 minus 1, and there's my factors. On the bottom, I'm going to do a 5 and a 3, x, 5, 3. I want a positive 5 and a negative 3 in order to get positive 2 in the middle. All right, so there's my factors. So remember, when you're finding vertical asymptotes, you set your denominator equal to 0. So you're going to set each factor equal to 0 and solve, and your vertical asymptotes are x equals negative 5 and x equals 3. Horizontal asymptote, remember that deals with the degree. Since the degree is the same top and bottom, our horizontal asymptote is the quotient of the leading coefficients. So whenever the degree is the same top and bottom, you just take the leading coefficients and divide them. So our horizontal asymptote is y equals 2. X-intercepts, where this is what causes your y to be 0. So for y to be 0, we would want the numerator to be 0. So we would set the top equal to 0. Set each of these equal to 0 individually, solve for x, and we're going to get x equals 1/2 or negative 6. So our x-intercepts are 1/2, 0, and negative 6, 0. Our y-intercept is what we get when we set all of our x's equal to 0. So if we set every single x equal to 0, we end up with negative 6 over negative 15, which equals 6 over 15, which equals 2/5. So our y-intercept is 0, 2/5. Our domain is going to be all reals except the vertical asymptotes, which again, you are welcome to write as x does not equal negative 5 or 3. I personally, I'm so used to interval notation, so I'm going to do negative infinity to negative 5, union, negative 5 to 3, union 3 to infinity. All right. Okay, so there's my domain. And now you know what's coming. We're going to sketch the graph. All right, so we have vertical asymptotes. You know what? I'm going to rewrite these real quick. X equals, let's just review. So x equals negative 5, x equals 3. Horizontal asymptote at y equals 2. X-intercepts at 1/2 and negative 6. So 1/2 and negative 6, 0. Y-intercept was at 2/5, 0, 2/5. And then our domain was all reals such that x is not negative 5 or 3. All right, so first thing I always do is sketch the asymptotes. So we have a vertical asymptote at negative 5 and a vertical asymptote at 3. Next, we want to sketch the horizontal asymptote, which is at y equals 2. All right, now I'm going to use my intercepts. I think I'm going to draw the graph in blue so you can see it a little better. So we have an x-intercept at 1/2, 0, and at negative 6, 0. All right, then we have a y-intercept at 0, 2/5, which is just like up here. Okay. All right, so now how does this graph work? Well, we know that the left side, we're going to follow the asymptotes going through that point. On the right side, we know we're going to be up in this part of the graph because we have no other x-intercepts. However, if you're unsure, just plug in a number that is kind of on the right-hand side of the vertical asymptote. So if we plug in a 4, so if I find y of 4, so I get 2 times 16, so 32 plus 44 minus 6 over 16 plus 8, which is 24 minus 15. Okay, so 32 plus 44 is 76 minus 6 is 70. 24 minus 15 is 9. So this is a little bit above 7, right? 9 times 8 is 72, so we're a little bit less than 8. So 1, 2, 3, 4, 5, 6, 7, somewhere around here. And that just tells us that we are in this section that we knew we were in. So plugging through that point and then following the asymptotes, try to make it smooth. Okay. All right, so there's that part. And now let's just plug in one more point in the middle here. We know it's probably going to go up this way and down this way. However, how do I know that? Well, the first reason I know it's not going to be some sort of a parabola-like shape is because there's no other x-intercepts. So it can't cross the x-axis again, which means it's got to go in either direction. However, if you're unsure, let's just pick a point and plug it in. I'm going to pick -2 because it's a nice spot kind of in the middle of these two asymptotes here. So if I plug a -2 in for my x, I get 2 times 4 is 8 minus 22 minus 6 over, let's see, 4 minus 4 minus 15. All right, so 8 minus 28, that's -20 over -15. So this point is positive 4/3. So at -2, we're up here at 4/3. I'm going to do one more just so that you can see that we are going to cross the horizontal asymptote in the middle here. So I'm going to plug in a -3 just so you can see it. I'm going to erase some of this just to give myself some space. All right, so y of -3, if we plug in, we have 2 times 9 is 18 minus 33 minus 6 over 9, let's see, minus 6 minus 15. All right, so 18 minus 39, well, 18 minus 38 would be -20, so we're at -21. 9 minus 6 is 3, minus 15 is -12. Okay, this reduces to positive, but we're still below that axis. Darn it. Let's see. 21/12, so divide by 3, 7/4. Yeah, we're still below. I'm going to do one more, and I'll do this on my calculator just to make it go quick, guys, so that you're not in this problem forever. So we have, oh my goodness, and my calculator died. We're just going to do it by hand. This is why these videos are so much fun. 2 times 16, 32, minus 44, minus 6. I can do math really fast. 16 minus 8 minus 15. All right, 32 minus 50 is -18. 16 minus 15 is 1 over -7. All right, now we're above that little root there. So 18/7 is something bigger than 2, and we do end up crossing it over, which we knew we would, but I just wanted to verify. So there's that, and there's that, and we just follow the vertical asymptotes. All right, so what we've proven here, when in doubt, plot points. Remember that the left end and the right end will always follow the asymptotes. The middle will follow the verticals, but it is not affected by that horizontal. Remember, the horizontal only determines end behavior. All right, last little review. Make an equation for this graph. This one's simple. Okay, so if we have to write an equation, just ignore the hole. Pretend the hole's not there. And just say you were writing an equation of this line. Well, let's see. The slope of this line is, if we go from a point to another point, looks like we're going down 2 over 1. So our slope is -2. And then our y-intercept would be 6, right? So easy peasy equation of a line. However, we do have to account for the hole. So where is this hole? It's at x equals 2. So we have to multiply this guy, top and bottom, by an x minus 2 in order to generate that hole. So our equation for this graph would be this guy right here. -2x plus 6 times x minus 2 over x minus 2. Because remember, when you have the same factor, top and bottom, that generates a hole. If you have it a factor only on the bottom, then it's a vertical asymptote. But if it's in both the top and the bottom, then you end up with a hole. Whoops, I wrote equals, but it just didn't come through. There we go. Okay, this is our main lesson today. So we're going to review how to add and subtract fractions, because rational expressions are really just fractions. So when you add and subtract fractions, of course, you all know that we need an LCD. For these two denominators, the LCD is 12, and you get it just by multiplying them together. So you just, you keep multiplying until you figure out what the least common multiple is of these two numbers, and it's 12. If you don't want to mess with the least common multiple, you can just multiply them together. But I'm telling you now that the least common denominator will make life easier for you. All right. So our least common denominator is 12. In order to turn the 3 into a 12, I have to multiply it by 4. But I can't just multiply the bottom of a fraction by 4. I have to also multiply the top so that I'm not actually changing the fraction, right? Because 4 over 4 is really just the same thing as 1. And then on this side, I multiply both the top and the bottom by 3, because that's what I need to multiply the 4 by in order to turn it into a 12. So now, coming down here, multiply 4 times 2 is 8 over 12 plus 9 over 12. And now you have an LCD. You don't add the bottoms. You just bring it along, LCD. So 8 twelfths plus 9 twelfths. Ask yourself, how many twelfths do I have? I have 17 twelfths. And you can leave it just like that. For this one, take a close look. If we multiplied them together, we get 32, but 32 is not our least common denominator. Our least common denominator is actually 8, and you want to go with which one is the lowest number that both of those denominators go into evenly. So all I have to do is multiply this guy top and bottom by 2, and so I end up with 2 eighths plus 7 eighths, which gives us 9 eighths. All right, so little practice on least common denominators. Let's carry it into what we're doing right now. So for this fraction, the denominator is x squared plus 1. Denominator is x squared plus 1. These two match, which means we don't have to do anything. We can go ahead and just combine. When you're adding fractions, the denominators don't get added. They're the same. They just come along. I have 2x squared over x squared plus 1 plus 2 over x squared plus 1, which gives me 2x squared plus 2 over x squared plus 1. Now, if you want to simplify your fraction, and we are going to have you simplify, see if you can factor the top. A 2 factors out of the top, and you're left with x squared plus 1 over x squared plus 1. Now, I love canceling, and I also don't like canceling. There are goods and bads to canceling. This one cancels beautifully. Isn't that gorgeous, right? And this whole thing just equals 2, which is is pretty cool. I love canceling. There's something very satisfying about it. However, you need to understand that sometimes if you cancel in a function, you're changing the domain, and you want to be very cautious about that. So, but here it's not a function. It hasn't been given a function name. It's just an expression. And the domain is all reals anyway, so we can go ahead and cancel with confidence. All right. Uh-oh. Denominators are different. We're going to have to find an LCD. So an LCD, if we have a 3x and a 5x, 3x and 5x. Well, both of these denominators contain an x already, so we don't need to do anything with the x's. We really just have to look at the two numbers and think, what is the LCD of these two numbers? Well, the LCD of those two numbers would be 15. So our LCD would be 15x, because we have to have an x in both of them, but we also need an LCD with the numbers as well. So what do I have to multiply this left one by, the denominator by, in order to turn it into a 15x? Just 5. What do I have to multiply the right side by to turn it into a 15x? I multiply it by 3. So what I end up with is, on the left-hand side, multiply the top, you get 30. Multiply the bottom, you get 15x. On the right-hand side, multiply the top, you get 9. Multiply the bottom, you get 15x. What is 30 over 15x plus 9 over 15x? It's 39 over 15x. And of course, you would want to reduce. So if we divide both sides, top and bottom, by 3, you get 13 over 5x. There are things sometimes you could, like this fraction, honestly, we could have reduced it before we started. We still would have had to go through the similar process of finding an LCD, but would have saved us from having to reduce at the end. Although really it's the same work either way. All right, now we have a 2 and an x, and we have a 7 and an x squared. So what we need is, we've got to have an LCD for our numbers and an LCD for our letters. So the LCD for the numbers would be 14. I'm gonna write LCD. All right, our LCD for our numbers would be 14, because that is the smallest thing that is divisible by both 7 and 2. Our LCD for our letters would be x squared, because that is the smallest thing that is evenly divisible by x squared and x. So my LCD is 14x squared. Now I look at my first fraction. What do I have to multiply 2x by to get 14x squared? It needs a 7 and it needs an x. So I multiply top and bottom by 7x. On this side, I already have the x squared. All I need is the 14, so I just have to multiply it by 2. So what I end up with on the left, 7x times 10 is 70x. Over 14x squared, plus 3 times 2 is 6 over 14x squared. So I end up with 70x plus 6 over 14x squared. Always look to see if you can simplify. I'm going to factor a 2 out of both terms on top. 35x plus 3 over 14x squared. And now I can cancel this 2 with the 14, and my final answer is 35x plus 3 over 7x squared. So we could have canceled this guy at the beginning. I tend to just go ahead and work it and cancel at the end, but you know what? It's potato, potato. You can do it either way. Be very careful. You cannot cancel this 35 with this 7. You can't cancel because they are not common factors. You can only cancel factors, common factors, things that are being multiplied. You can't cancel terms that are being added. So be very careful about canceling, proper canceling. Oh my goodness, what have we got here? When you have these more complex denominators, your favorite F word, what's our best friend? Factor. So the first thing you're going to want to do is factor everything. This has a GCF of a 3, so it factors into 3 times x minus 4. This guy is a trinomial, x minus 4, x plus 3. I'm going to write these out, LCD. So I have a 3 and an x minus 4 in my first denominator. I have an x minus 4 and an x plus 3 in my second denominator. My LCD has to have everything in here so that it's the smallest thing that both of these go into evenly. So it's going to have a 3. First thing we do is we look at our numbers. Has to have a 3. It's certainly going to have an x minus 4. And it's also going to have an x plus 3. Now you check. Does this denominator go into this evenly? Yep. Does this denominator go into this evenly? Yes. So as long as both denominators can go into our LCD evenly, we're good. Let's look at the first fraction. What do I have to multiply this by in order to get our LCD? Well, it has the 3, it has the x minus 4, it needs the x plus 3. So I'm going to multiply my first fraction by x plus 3 over x plus 3. All right, now let's look at the second fraction. Second fraction has the x minus 4, has the x plus 3, but it doesn't have the 3. So all I have to multiply this side by is 3 over 3. All right, so now I'm going to kind of mark this off so that there's a little space here. So if we multiply the top, and I'm going to go ahead and distribute, we have 5x plus 15 over our nice, beautiful LCD. Plus, and now let's do this the right side, 9x plus 3 over our beautiful LCD. All right, let's combine. If we combine like terms, 5x plus 9x is 14x. 15 plus 3 is 18. On the bottom, 3 times x minus 4 times x plus 3. If we factor a GCF out of the top, the only thing that goes into both of these evenly is 2. So I have 2 times 7x plus 9 over 3x minus 4, x plus 3. There is nothing that can cancel. We are done. Okay, almost done. So this next one, we have two just different denominators. So our LCD has to be evenly divisible by both of them. So you just need to have both factors in it. So I'm going to multiply the left side by x plus 1 over x plus 1. I'm going to multiply the right side by x plus 5 over x plus 5. On the left, now I'm going to erase these, just give myself some space. On the left, go ahead and distribute it out because you're going to have to combine like terms anyway. So on the left, if I come down here, I'm going to kind of rope that off. I have 3x plus 3 over my LCD. And I'm subtracting. Let's be careful at that. 4x plus 20 over our LCD. All right, now here's where the subtraction actually is important. You're subtracting every single term in this expression. So this negative applies to this whole thing, not just the first term, the whole thing. Now, I tend to go ahead and just keep the negative here. Some people like to turn it into a plus sign and then put the negatives inside, like with each of the little terms. I personally like to just subtract. So what I do is I think, what is 3x minus 4x? That's negative x. What is 3 minus 20 is negative 17. So I just like to subtract kind of more mentally. But if you want to turn this into a plus sign and put little negatives up with the terms, that's fine. The only other thing we could do really that would be kind of nice would be to pull out a negative. But there's no common factors. There's nothing you can cancel. So this is pretty much all we can do. All right, let's put it all together. So this first one factors into 2 times x minus 1. So I'm just going to replace it with that. My next denominator factors into x minus 3 times x minus 1. So I'm going to replace it with that. My LCD. So I need a 2 and an x minus 1 from my first denominator. I have an x minus 3 and an x minus 1 from my second denominator. So my actual LCD, it has to have a 2, it has to have an x minus 1, and it has to have an x minus 3. Notice I don't list the x minus 1 twice. You just need it one time for both terms to be evenly divisible into this guy right here. As long as both denominators go into your LCD evenly, you're fine. So you do not need that x minus 1 to be squared, just once for each time you see it in each denominator. All right, so first denominator multiplied by what it's missing, which is the x minus 3. Come on. Having stylus issues. There we go. Second denominator, only thing it's missing is the 2. All right, so if we multiply out, look at this first one. What do we end up with? We have to do a little bit of foiling. So you don't just multiply like the negative 3 times the x. You have to do the full distribution. It's the quantity x minus 3 times the quantity x plus 2. So we get x squared plus 2x minus 3x minus 6 over our LCD minus, just for kicks, we throw in a subtraction. So distribute the 2, negative 4x minus 2 over our LCD. Now, in all honesty, this is really silly. We have minus and minus, negative, so you could just turn all these into pluses and distribute that negative in and make your life easier. All right, there are no other x squareds, so we just have that one x squared. 2x minus 3x is negative x, plus 4x is plus 3x. Negative 6 plus 2 is negative 4 over 2 times x minus 1 times x minus 3. Now let's check. Does the top factor? Yes, it does. You should factor it. So it factors into x plus 4 times x minus 1. And look, we can cancel. Now, I'm just going to warn you, when you get into higher maths, if you cancel this x minus 1, you're actually, if we were in a function mode, you're changing the domain of your function. So when we cancel it, in order to, if we wanted to do that, we would have to somewhere mention, hey, x can't be 1. So this is true as long as we restrict our domain and say, well, this is our function, x plus 4 over 2 times x minus 3, but we got to mention that our x cannot be 1. There's actually a hole there. So this is why I warn against canceling, but we are going to need it a lot for our next lesson. Last one. Oh my goodness, 3 denominators. We can do this. 3 times x minus 4. You know, you might want to go ahead and just try this, like stop the recording, see what you can do. See if you can do this on your own and then start it up again. All right, so there's our 3 denominators. So we end up with, so our LCD, I'm not going to do the whole process. Let's see if we can just figure it out. It needs a 3. it needs an x minus 4, and it needs an x plus 3. That makes it, let me change colors here. All right, it is evenly divisible by this guy, yes. Evenly divisible by this guy, yes. Evenly divisible by this guy, yes. Each component just goes in one time for as many times as you see it in each individual denominator. Okay, I'm going to write in blue for a second when I write what I have to multiply by. So this first term, I got to multiply by an x plus 3. This middle term, I just have to multiply by a 3. So I'm going to kind of squish it in here by a 3. And then the last term has to get multiplied by all those factors. All right, so let's multiply out the first term. So the first term, if I distribute the 5 times the x plus 3, I get 5x plus 15 over my LCD. By the way, you don't have to put them all individually over the LCD. You can kind of skip that step and kind of put them all over one LCD in the very first step if you want to. But, this is our first time doing it, so it's kind of good to write out the steps. Okay, 3 times the quantity, 3x plus 1, is 9x plus 3 over our LCD. By the way, notice you never, ever, ever distribute the denominator, but you always distribute the numerator. That's really important. The denominator is always kind of like factored, it stays factored. But the numerator, you have to distribute out because you're going to have to combine like terms. So you have to distribute everything. So I'm going to go ahead and do my distribution kind of as a little side step. So I'm going to do my distribution in red over here. So I have 2 times x squared plus 3x minus 4x minus 12. So my last numerator is going to be 2x squared plus 6x minus 8x minus 24. And I wonder if it will let me move. I wish it would let me select whole things. It just doesn't. Nope, it only lets me select individuals. All right, well, it's just going to have to stay in the way. All right, or you know what? I can just erase it. There, give myself a little more space. So let's do our maybe we just combine these first two terms first. So we have 5x plus 9x is 14x. 15 plus 3 is 18 over our LCD minus, and I'm going to combine terms in here. We have 2x squared minus 2x minus 24 over our LCD. So when we subtract, be so careful. Make sure you distribute this negative to all of these terms. I'm going to start with my x squared because I like to have things in descending order. So I'm going to have negative 2x squared. Next, I do x's. 14x minus negative 2x. Minus negative 2x is plus, so I end up with 16x. And then 18 minus negative 24 is the same thing as 18 plus 24, which is 42. All right, we got to factor the top. First thing I'm going to do is factor out a negative 2. And keep the bottom factored. All right, so the only factors of 21 are 1 and 21 or 3 and 7. None of those are going to combine to give you 8, which means this is fully factored, and we are done. All right, that is it. That was the hardest one. Hope you did well on it, and we will